Hi everyone, in this section we will implement an API gateway using Springcloud Gateway. Let's create a new module called Gateway Service and start adding required dependencies. We first need Springcloud Starter Gateway. Then we will add Netflix Heroka client as this service will also register itself to Discovery Service. Then we need Starter Data Redis reactive dependency to be able to use Redis for rate limiting. And then we add Starter Circuit Breaker Reactive Resilience4J dependency to use Resilience4J as the circuit breaker component. For this new dependency, we will set the version 1.0.5 in the main pom.xml file. Additionally, we need starter config and security to use config server. And then we need Lombok dependency. Finally, here we also specify the Spring Boot Maven plugin to create a Docker image for this gateway. Let's now create configuration files. First, application YAML file. We will only have logging here as the other configs will be in the config server. Then we create logback.xml file as usual using the common logback file. Then we will create bootstrap YAML file and then set application name and profile gateway. So as you know, we need a config server file now that has this profile in the name. So here we have a config client gateway YAML file. Here we set gateway service properties to be used by Resilience4J configuration. I will explain them when we configure it. We then set the port as 9090 and then configure gateway. We set the ribbon enabled to false because we want to use Springcloud load balancer. Then we also set gateway discovery locator enabled to false. This is because we want to customize root definitions here in the config instead of getting them from discovery as pre-configured. Because by default, Discovery Locator adds the roots with the name starting with Reactive Composite Discovery Client, so our explicit roots will be overwritten and omitted if Discovery Locator enabled. We have three roots here. First one is for Elastic Query Service. We set the URL as lb Elastic Query Service here, so here lb means that Elastic Query Service name will be fetched from Discovery Service. For predicate, we used Elastic Query Service and wildcards to match all paths that starts with Elastic Query Service. Then we rewrite path to get only the last part, that is the part that comes with ***. So we will remove the context paths from services to make the URL simple, as we will discuss shortly. Note that with this configuration, gateway will take the request and then forward it to Elastic Query Service with URI that ends with whatever comes in place of these wildcards. We also set request rate limiter filter here, where rate limiter uses token bucket algorithm, which will fill tokens in each second and spend them when user requests. We set replenish rate to 5, which will limit the request per second to 5. That is, client can only send 5 requests per second without dropping the requests. And this value is used to fill the token in the algorithm. We then set burst capacity to 10, and this one will give a temporary burst to client. For example, if client sends 10 requests, it will be allowed although we set 5 per second limits. But in this case, client won't be able to send until 2 seconds passes, because it already used the reserved tokens that could have been spent in 2 seconds. And with key resolver, we specify the key resolver bean with a Spring expression here. Note that we will define this auth header resolver in the gateway config class shortly. And then here we have the circuit breaker, which will return a fallback result using a fallback controller in case a service is not reachable. We will create this controller shortly. And we have the similar configuration for Analytics Service and Kafka Stream Service. Only change the definitions in ID, URI, predicates, filters, and the fallback controller. Finally, we also set the Redis host as localhost here to be used in rate limiting. Alright, I will first create Spring Boot application class, which is a usual startup class, then create a web security config to allow all paths. As for now, we won't apply any security here because we are applying it on the forwarded services. That's a design decision. We may want to apply security here and remove from services or apply for both, but it is safer to use security on service itself because service can be called from somewhere else instead of gateway. So here in the security config class, we created a bean that returns security web filter chain and use permit all methods for any exchange. And also we disabled CSRF as we only have a backend interaction with the gateway service. After configuring HTTP security object to permit all, we simply build it to create security web filter chain and then return it. We then create gateway config, but for this one first we need a config data class to fetch the configuration data. So let's create this config data class first and then continue with gateway config. We give the name gateway service config data for this class and specify the prefix as gateway service, as we defined it in the application YAML file. And we simply create the required fields to access the configuration we defined in the config file. Let's return to the gateway config class implementation. Here we will have a bean for key resolver, which will be used by rate limiting filter. If we return a constant here, it will apply the rate limiting to whole application, not per user or client. So we will use the authorization header here to apply the filtering so that different clients won't use each other tokens. We set the bean name here, and remember we have used it in the rate limiter configuration. Then we define circuit breaker configuration and set the required config to be used to decide to open the state for a service, which will cause to be redirected to fallback controller. We will configure reactive Resilience4J circuit breaker factory with the configure default method. And first, set the time limiter config to set a timeout duration for the operations on circuit breaker. This is to prevent waiting indefinitely. Then we configure circuit breaker and set the failure threshold, slow call rate threshold, slow call duration threshold, permitted number of calls in half open state, sliding window size, minimum number of calls, and wait duration in open state. Finally, we simply call the build method and return a customized reactive Resilience4J circuit breaker factory. So here we set failure rate threshold to 50% and then set sliding window size as 10. So for each 10 records, if more than 50% timeout, then circuit will be opened and requests will be sent from the fallback. And during open state, it will wait for a time configured with wait duration in open state. After this time passes, the state will be switched to half open, which means that incoming requests started to process again. But we also limit the number of permitted requests in half open state here, and it will check the percentage in the half open state again to decide to open or close the circuit. Alright, let's now add two response models, one for query service and one for analytics and Kafka stream services. For query service, we will return a string fallback message, while for analytics data, which is word count, we will return simply 0, so we use a number here. We can then create the fallback controller with path mapping, fallback, and with the REST controller annotation. Then we will create query service fallback with query-fallback path and return response model we created with a simple fallback message. Note that this method has to have post mapping instead of get to work with gateway service. Then we add analytics and stream services fallbacks methods similarly and then set the word count as 0 this time. Let's once more compare the configuration and implementation. As you see, we use the key resolver bean for rate limiter config, and the fallback controller is used here in the gateway circuit breaker filter. As you see, we set the path mapping for the fallback controller in the config. Great, in the next section we will update the Docker Compose definition and some configurations, then run everything together in a single Compose file. I'll see you in the next section.